the video for our step-by-step binder lesson, Systems of Equations by Elimination, hard problems. So even though these ones are harder to do by elimination, that doesn't mean that we should try to use a different method. They're still good problems to do with elimination. They just take one extra step. But let me just talk about why they're good for elimination. We still have like terms lined up nicely. We just don't have a zero pair yet. So because the like terms are lined up nicely, elimination is still the better method, but we're going to have to work to get that zero pair. So, step one. All right. If you don't have a zero pair, you have to make one with multiplication. All right, that says multiplication. If you don't have a zero pair, you have to make one with multiplication. So look to see if the coefficients on like terms are multiples of one another. All right. And so, multiples are numbers that can be reached. You can reach the bigger number from the smaller one by just multiplying. So let's see if that works with x on our first example here. Can I get to a 9 from an 8 by multiplying that 8? Nope, doesn't work. But if I look at y, can I get to a 14 from a 7? I'm ignoring the sign right now. Can I get to a 14 from a 7 by just multiplying that 7? I can. 14 is a multiple of 7. I multiply 7 by 2 and I get to 14. So that makes this problem a little bit easier. It still isn't as easy as just having a zero pair, but because they're multiples, we can move on to step 2, which is multiply the entire, let me fit my R in there a little better, the entire equation with the smaller term by, we'll say, the number needed to form a zero pair. All right, so I know that there's a lot of words there. This is going to make more sense the more we practice it. So I see that the top equation has a 14y. The bottom equation has a negative 7y. The zero pair, so this is the one with the smaller, the zero pair of a positive 14y is a negative 14y. So what do I multiply my minus 7y by to get a negative 14y? Well, I multiply it by a positive 2. That way it stays a negative 14. I need to get to negative 14. I'm at negative 7, so I multiply by 2. In the top equation, I'm just going to copy it. And so I'm going to write a times 1. That means I'm not changing anything. If I multiply anything by 1, it doesn't change. I'm going to rewrite my system. So negative 9x plus 14y equals negative 14. All right, the bottom equation is going to become 16x minus 14y equals positive 14. All right, line right there. Keep my steps separate here. All right, so step 3. I'm actually going to write what I just did there. So copy the unchanged equation and the multiplied equation. on top of each other. And add the equations together. Okay, so I put that addition line there. I'm going to put a little plus on in front. This is my new system of equations. I can almost forget this old system, but I might come back and use it in just a second. I'm going to add together my like terms. Negative 9x and 16x combined to be a positive 7x. These terms are now a zero pair, so they eliminate. And negative 14 and 14, those are also a zero pair, so they just become a 0. I still have to write something on this side. All right, let's just write down what we do next. Although at this point, if you can solve it the easy way, the steps are going to be identical now. Solve for the variable in the combined equation. That's step 4, and I'll go ahead and add in step 5 now. And this is very similar to our easy step-by-step binder. We plug in the value into one of the original equations and solve for the remaining variable. Okay, still leave some space down here because we still need to talk about what to do when we can't get a zero pair by just multiplying one of the equations. But let's go ahead and finish up this first problem that we were working on. Let's recap what we've done so far. We didn't have a zero pair originally, but we recognized that 14 is a multiple of 7. So I could form a zero pair by multiplying the whole bottom equation by 2. When I did that, I got this equation. I lined them up, added them together, and the y's eliminated. I can even cross them out now because I'm not going to use these equations again. And now I've got an equation with just an x. I can finish solving by dividing both sides by x, or 7, and I get x equals 0. All right, now I take the value I found for x, plug it into either of the equations. I'll just plug it in right here. And this now becomes 8 times 0 minus 7y equals 7. This term goes away. 8 times 0 is just 0. Divide both sides by negative 7. And I get y equals negative 1. I want to write my answer as an x comma y, so that becomes 0 comma negative 1. All right, and 0 is just part of the answer. Some students, when they get 0, they think that that means no solution or infinite solutions, but you need all your variables to cancel for that to happen, and that's not what happened here. We just got x equals 0. That's a fine answer. We plugged it in. It's actually very easy to plug in. We got a negative 1, wrote our answer as an ordered pair. All right, let's look at problem number 2. See if we can do it with these 5 steps. So I don't have a zero pair. Are any of my coefficients multiples of one another on the same term? Let's look at the x's, 7 and 14. Oh yeah, we just saw that. 14 is a multiple of 7. Is it easier to do it with the y's? Nope, 4 and 3, that's not easier. And the coefficients, it doesn't matter because that won't eliminate a variable. So here's something we can do with this one. Instead of copying down this equation off to the side, I'm going to copy this equation right underneath this one. But I need to form a zero pair. The zero pair of 14 is a negative 14. I get that from a 7 by multiplying by negative 2. So I'm going to multiply every term by negative 2. So I get a negative 14x, a negative 8y, and a positive 42. Negative 21 times negative 2 equals a positive 42. Now this equation has been changed, so I can even cross it out. I can now add these two equations together And let's see what I get. The 14x and the negative 14x, those cancel out. The 3y and the negative 8y, those combine to be a negative 5y. And the negative 7 and the 42, those combine to be a 35. All right, finish solving this. Divide both sides by negative 5 to get y equals negative 7. Plug that back into either of the equations. I know I crossed out that top equation, but you could still plug it back into that one if you wanted. I'll plug it into this one, which you can still see the numbers for, and I get 14x plus 3 times a negative 7 equals negative 7. And let's finish solving. We have 14x minus 21 equals negative 7 over a constant over 14x equals 14, divide by the 14, and we get that x equals 1. All right, so I got 1 comma negative 7, right as an ordered pair, box your answer. Okay, this is going to work for problem number 3. So let's just use our 5 steps in problem number 3. 10 is not a multiple of 9, so we can't do with that. But this is a 1y, and everything is a multiple of 1. So I can get my 0 pair by multiplying everything down here by 11. So I get an 11y to be the 0 pair of this negative 11y. So I'm going to write that off to the side. I'm multiplying everything by 11. Just going to copy this one. So times a 1. And I get 10x minus 11y equals 20. And 9 times 11, that's 99. X plus 11y equals 11 times 18. I want to say it's 198, but not a bad one to double check in the calculator, which I should have had ready. Learn from my mistakes. Here we go. 18 times 11, 198. Add these together. Now that I've got a 0 pair, I get 109x. The y term cancels, equals 218. Add these together correctly. Divide by that 109, and that divides in nicely to get that x equals 2. Plug that 2 back in wherever we want. How about right there? We get 9 times 2 plus y equals 18. 18 plus y equals 18. Minus 18 minus 18. Y equals 0. Write it as an ordered pair. 2 comma 0. Okay, and that brings us to problem number 4. And this is where we run into another problem. 9 is not a multiple of 8. 7 is not a multiple of 6. So, what to do? We'll call this step 2.5. Or is it better to call it 1.5? Let's call it step 1.5. And we'll go fit it in. So, if you don't have multiples, then multiply both equations. To form a 0 pair with the least common multiple, LCM. Hopefully you remember what that means. Least common multiple, we use that with fractions a whole bunch. Okay, so that means I'm going to probably want to focus on my smaller coefficients, the 6 and the 7. All right, their least common multiple is 42, and I get that by multiplying them by each other. I'm going to multiply this negative 7 by 6, so I'm multiplying everything in that top equation by 6. But I don't multiply this 6 by a negative 7. I multiply it by a positive 7, because let me think this through. When I multiply this by a negative 6, I'll get a negative 42y. Well, I want that's 0 pair, so I want a positive 42y. So by keeping these both positive, because these are already 1 negative, 1 positive, I will get a 0 pair instead of an identical pair, which is less convenient. All right, let's see what we get. We get 48x minus 42y equals 36. And multiplying everything in this by the 7. Negative 63x plus 42y, there's my 0 pair, equals negative 21. All right, and then I can just follow steps 2 through 5 on my way out here. So add these two together. 48 plus a negative 63. Need the calculator for that one again. 48. Get a negative 15x. My y terms cancel. Add these together, I get a positive 15. Divide by that negative 15 on both sides. And get x equals negative 1. All right, plug that back in wherever we want. Just plug it in right there. I get negative 9 times negative 1 plus 6y equals negative 3. 9 plus 6y equals negative 3. Take the 9 away. 6y equals negative 12. Divide both sides by 6. And I get, just one more space, y equals negative 2. Put these together into an x comma y, I get negative 1 comma negative 2.